Okay, in question 8, 9, and 10, we are given determinate point coordinates of the vector r, and we are asked to calculate the related angle, the standard angle, and evaluate the three trigonometric functions. Now notice here this coordinate, the first one, -3, represent the x-coordinate, which is basically the projection of this vector here on the x-axis, -3, while the 4 represent the projection of r on the y-axis. So this will be +4. This point is 4. So if you think about it, the x component of r will be -3 because it's the projection as well on the x-axis. So this will be the x component, and this is in the negative x direction, -3, while the +4 will be the y component of r. So this one here, +4, and this one of course is equal to this one. Remember this one here, this length, this magnitude is equal to this magnitude. So this is basically our right angle triangle. This is the right angle here, and this is the related angle, theta sub r. Now how can we calculate the related angle? Now notice here you can see the right angle triangle, this one here. This is the right angle here, and this is the related angle. And we know that this length is +4, while this length here is 3 or -3. In terms of magnitude, this is 3. Now, how can we calculate the angle? That's what we are asked to find, the related angle. We are given the opposite. The 4 here represent the opposite to the angle, and the 3 represent the adjacent. We are not given r. The hypotenuse is not given to us. But we know how to relate the opposite to the adjacent with the angle. It's through the trigonometric function tangent theta. So now in that case, it's the related angle, and tangent, the related angle, is the opposite, which is 4/3, and we need to calculate theta. So in order to calculate theta, we need to take tangent inverse of both sides. When you take tangent inverse of the tangent, it will leave you the angle. So this will be theta sub r. And then we take the tangent inverse of 4/3. And if you plug the values into the calculator and make sure you set the mode at degrees to get the angle in degrees, this will yield 53.1 degrees for the related angle. Now to find the standard angle, we need to look at the location of the r with respect to the quadrant. Now r is located in the second quadrant, so the standard angle will be the whole thing here, 180 minus the related angle. So 180 degrees minus theta sub r, since they are in the second quadrant. So the standard angle will be 180 minus 53.1, and this will yield 126.9 degrees for the standard angle. Now, since we have the standard angle, we can calculate the trigonometric function directly by applying them on the standard angle. So we'll take sine 126.9, and you should know that the sine will give you a positive value since it's located in the second quadrant. In the second quadrant, sine is positive, while cosine and tangent will be negative. So whether you use the related angle to calculate the trigonometric functions or the standard angle, you will get the sine to be positive, the cosine and tangent will be negative, and you get the same values whether you use related angle or standard angle. The only difference, in the case of related angle, you have to add the sines yourself, while if you use the standard angle, the sines will be correct out of the calculations. And I'll let you do the calculations. Now for questions 9 and 10, it will be the same steps. You'll do the same steps to calculate the related angle using the coordinates here. And the only difference here is the location of the r. In question number 9, it's located in the third quadrant. So after you find the related angle, which is this one here, you have to add 180 to it to find the standard angle. So standard angle will be 180 plus the related angle, while in question number 10, R is located in the fourth quadrant. And this will be the related angle, this part here. This will be the related angle. So to calculate the standard angle, you have to subtract the related angle from 360, because the whole thing here is 360. And to get the standard angle, which terminates at this point, you have to subtract the related angle. All right, I hope you found this video educational. Thank you.